So we went through this process a bit earlier. I got off in 2000, and we gradually worked through the question of what we reduce as our softer and our science and technical areas at DOC. Just first a little bit of introduction through. I'll just skip through some pretty pictures of DOC, the conservation things. You'll be aware that about a third of New Zealand's land is in conservation management. It's about, also DOC's responsible for conservation heritage of historic sites on conservation land, as well as natural heritage. Plus there's 30 marine reserves, or more than 30 marine reserves in marine protected areas. Responsibility for protecting indigenous biodiversity of many unique species. Kiwi, for example, which is threatened due to stoats, and where we see some statistics coming in. There's a graph, in fact, of a survival analysis of Kiwi chicks under stoat control and no control, and you can see why without predator control, the Kiwi population of New Zealand, North Island brown Kiwi in this case, is declining rapidly without intervention of conservation managers and local support groups. Tuatara, another unique New Zealand species. Here we see an example of tuatara responses to rat removal on various islands, looking at the percentage of juveniles in the population before eradication and after eradication, as published in conservation biology. Marine mammals, plants, pingao, trying to restore the plants on foreshores, and of course many of you will be aware that we have invasive threats to our unique flora and fauna that's already led to a lot of extinction. Thus DOC also, the other half of DOC, is responsible for promoting recreation. Places like Tongariro alpine crossing. Here, for example, we see some statistics coming in, generalised additive model showing crowding on the Tongariro alpine crossing in relation to the daily track count. How did people on the track perceive crowding relative to the number of people who walked the track that day? This was analysis of data from a survey on the crossing, which indicates that there looks like there's a plateau in between about 300 and 800. But once you get beyond that, things increase rapidly again. And there's up to thousands of people cross sometimes the Tongariro alpine crossing in one day. It's very top of the list of Local Planet's Guide for visitors to New Zealand. And the conservation has a role for facilitating tourism, for example, in Fiordland. In fact, I hope that later we'll look at an example data set about tourism in Fiordland and some issues there as well. DOC has about 1,800 staff, several hundred science graduates doing science and technical work at national, regional and local levels. It's sort of more national shared service centres and local levels since the latest restructure. And effective conservation management requires evidence based on data. Typical questions that we come across are things like, what are the trends in abundance and health for native species and ecosystems? How can management make a difference? How do we deal with threats effectively? And looking away from the biodiversity side to the visitor side of things, how are visitors using parks and facilities? What sort of visitor issues need to be managed? How do we prioritise them? And so on. So effective conservation management requires evidence based on data, and there's been a big push throughout government for management that the government is doing, conservation and tourism or wherever, to be increasingly based on evidence based on data, and that prioritisation of our work should be done in this way as well. And trying to answer some of these questions in biodiversity is even more difficult than doing in places like tourism. It's not so easy. You can't go out and do a survey of Kiwi or the Pihutikawa to see what the problems are. It's a difficult field work and real science and analysis required in very uncertain circumstances. For effective conservation, we need to move beyond qualitative statements. Demands quantitative assessments based on data, and statistics are essential. Internally, we need evidence to know what to do and how to prioritise work that we're doing. Externally, we need to demonstrate making a difference and have evidence to maintain our funding and evidence to maintain the support that we're getting from partners in the community and business and elsewhere. DOC has had one permanent statistician since 2000, and I learned 2 hours ago, greatly to my pleasure, that we have actually now established a second permanent position after 6 years. So that's great news for me this morning. But anyway, we have statistics. Infrastructure is one area that we take care of, particularly software, and that's one of the aspects we're looking at today. Training is, when I started at DOC, it was, I think one of the main things emphasised in the job advertisement was power analysis and design. That's a very important part of it. But what I found was going to be the most effective use of my time as initially a sole statistician was going to be making other people more effective using statistics. And so training has been a big part of our role at the Department of Conservation. Consulting, design, analysis, involvement in our own projects and development, and so on. And statistics skills are needed throughout the organisation, but one particular area that we emphasised initially is statistical modelling skills, which is essential for leading science and technical staff. And particularly starting from the linear model through its extensions to things like mixed models for repeated measures of typical design, for looking and monitoring trends through time in the work that we're doing. So how do we go about meeting these needs at the Department of Conservation? As I mentioned, training is an important part of that. Increasing statistical skills was set as a priority. We've developed and promoted courses using a mixture of in-house and external expertise. But significant ones have been developed in-house with an initial emphasis on analysis because, as is true for many organisations, I'm sure, but was particularly evident at the Department of Conservation, much more data is collected than is ever analysed. In DOC, we suffer from the rainy day problem in particular. The data is put aside to be processed, let alone analysed, until there's a rainy day. When the rainy days come in winter, when the field season isn't there, there's time to go on leave, there's all those other things that need to be done, and there's a limited amount, there's an awful lot of data sitting there never used. And if data's not used reasonably soon after it's collected, I maintain it dies. But it hasn't got the people who originally collected it who remembered what was to be done with it, it dies. You can see a few nods in the audience there. Anyway, we did a survey in about 2009 looking at all the routine biodiversity monitoring projects that were taking place through the 11 or 12 conservancies of DOC at the time, and we scored this on a series of assessment questions, and we see our mean score on these different areas of the questions that we broke up into 7 areas. We found the weakest area was data analysis. So in 2009, I actually finally got the data to support the conclusion I reached in about 2001 that we needed to emphasise analysis. Other areas that need emphasis, obviously, from a key statistical point of view, is the whole question of sampling design. We've been working on that as well. These other areas of reporting and continuity review are more things that statistics are supporting. These are the ones I would argue that are the core ones. The statisticians, data collection to some extent, that's largely a field question. The sampling design and data analysis are key areas. And both of them are weak areas, weaker areas in terms of our assessment of DOC needs and monitoring. So statistical modelling, support for analysis is a key area. Why we developed courses in-house? Why didn't we send people to universities and so on? Because most of our data is observational, not experimental. We're interested in emphasising the size of effects more than we are in testing hypotheses. Size of effects with confidence intervals are much more important for management, and in fact I would argue for most purposes, but it's very clear when you manage it that that's what you need. Not a hypothesis test usually, occasionally it'll be a useful framework. But the university focus is mostly on designed experiments rather than observational data. That's certainly true in the biological, ecological and other harder sciences. Not so true in social sciences, of course, although still in psychology, still very experimentally oriented. So, and social sciences more generally will try, you should do experiments when you can and have got the resources to do so. I absolutely argue for that, but our ability to do it, the sort of data that we're collecting pushes us much more in the direction of observed data. Our university courses, we have students who arrive with a knowledge of designed, or graduates who arrive with knowledge of designed experiments, hypothesis tests, and ANOVAs. And that's an inadequate framework for modelling observational data. It may be useful, but it may not be the most. I got a little tired in my first year or so getting questions, how do I apply an ANOVA to this data? And I'd say, well, I'm not sure I'd start with an ANOVA with that data. Count data in an observational framework? Probably not. So we developed a 3-day internal course with assistance from people outside, Jennifer Brown at Canterbury University, particularly comes to mind. And we were drawing together ANOVA and regression into the linear model, extending this to the generalised linear model, particularly focusing on logistic and Poisson regression. Why? Because a lot of our data that isn't simple measure data is binary or count data. Very common. Got these modern techniques developed over the last 30 to 40 years, and we need to make those available to people who've been only educated in ANOVA and possibly in linear regression. And, just an aside, when I came to make the evaluation, logistic regression was barely available in SPSS and Poisson regression wasn't. And in fact, SPSS was the software at that time. I'll come back to it. We also run courses on graphing, a little bit on using our software effectively, although we built that in. My philosophy is that if you're teaching statistics, you teach statistics and not software. Software tools, but you want good tools. And if time in our statistical modelling course, if there's a reasonably quick class, then we'll introduce generalised additive models and or tree-based, recursive trees, classification regression type approaches. And in our courses, each student works at a computer, accessing data, creating graphs, applying models, either as the training demonstrates and or in exercises at the end of each session dealing with the sorts of topics I've been outlining. We use real data from doc. Absolutely essential when you're teaching on the work site is to use data that people, preferably their own data. That's what we found at MBIE, made a huge difference. Once we started teaching, when we were able to get people to a level where they could start doing work that would be immediately applicable, not necessarily immediately applicable to what they were doing, but they could see could have potential to be applicable to the work and the data they were already using. Context and relevance of data is essential, I would say, not just very important in teaching in the workplace. Statistical software, we use R. It's amazingly powerful and flexible. It's free, as we've already discussed, but has a steep learning curve. I don't know, maybe I should take that steep out. I think it's perhaps a little bit misleading. I'm going to say it's got a learning curve. We'll come back to this at the end and discuss some of the lessons we've drawn. I draw them together at the end about the learning curve. At DOC, we used SPSS from about 1998. SPSS Plus was added for the upper end of analysis in 2003 because of those inadequacies in SPSS, notably the lack of a full generalised linear model with Poisson regression. In fact, I checked the other day and found that at least in 2010 and possibly more recently, I wouldn't have been able to do a generalised additive model in SPSS. So R replaced S Plus in 2006, and we dropped SPSS and the price went through the roof in 2008. We're only keeping it for heritage anyway. So what are the barriers to adoption of code? We found at DOC that typing code was new for most. People were used to point-and-click menus. And we've found that R Commander helps. Who's used R Commander? Great. Who's heard of R Commander? A few more? Good. It provides a menu-based interface to R, which provides a bridge to R code. For some users, it might be sufficient, particularly if they're occasional users with basic functionality. But it's a bridge that allows people to learn a lot about R reasonably easily, and it's one of the key aspects of reducing the learning curve that we've found. And we've converted our basic 3-day modelling course that I just outlined to using R Commander and haven't looked back. Works very well. Most recently, we're actually converting that course to use ggplot for its graphics, because there is a ggplot. So who's heard of ggplot? Lots of people have. If you haven't, well, learn about it. Ggplot's the best thing since sliced bread for graphics. And it's an interface in R Commander that allows you to create ggplot graphs quickly. Slightly complex code, but you can learn from it, and you can learn to use ggplot just by letting R Commander do some of the hard work shortly. We'll do a demonstration on that shortly. Okay, so let's demonstrate R Commander. Let's see if I can find R. Top there. Thank you. So to open R Commander, you need to download R Commander, and I would recommend it's ggplot add-in as well. So we don't need to worry about it. I'll just change the font slightly. Okay, packages. We then need to load a package. R Commander and the ggplot add-in are just packages with an R that you need to load off the internet. Not too hard if you've got a good internet connection. A bit more complicated if you're tied down a place like doc or MBIE, but we've achieved it. Both doc and MBIE, with only one reservation at MBIE at the moment. One small one, significant one though. We want a package, load package, and we go through the packages, all the packages we might have downloaded. And we can either choose R Commander, or better still, if you want, if you've got the ggplot add-in, you can just choose the ggplot add-in, and R Commander comes for you immediately. I hope. Most places it does. It does at dock, it does on this personal computer. It doesn't at EMBIE for some reason.
I think you need to double click.
Yeah, we can increase that.
There we go. Okay, so here's R Commander. And R Commander comes with 3 windows, which I'll come back to in a minute. A script window, an output window, and a message window. Probably more useful to describe those when we've actually done something. So let's get some data. Data, import data from text file. Quite easy to do from our menus. 2 things we do with this. We need to do with this slide. First of all, we need to be tidy people and to give our data set a name. And call it Milford, because that's where it came from. And the other thing we need to do is, I'm using comma-separated variable files because I found them most convenient, and so we need to say that we're using a comma as a field separator. That's really the only thing we have to change from the defaults. We need to change the name to be good, tidy programmers. That's what we need to do. Okay? Then we go off into Microsoft world, Windows world, and we need to find the data, and there it is, milford.csv. And what have we got? We can now see what these windows are doing. In the top window, we get repeated back to us the code that was created from our menus. It's kind of a little bit different to your standard GUI, because it throws you back the code explicitly right in your face. Why? Because that's what it was designed for. It's designed as a bridge. It looks, if anybody's familiar with SPSS, it looks rather like SPSS, and some of the menus do, but it works kind of different. A lot of it looks familiar if you've seen SPSS, but the code's created for you to see, so that at the top end we've got the script that was created. Then we see the output window, which spits back the code and anything else, any output that would come out from that code. And then at the bottom we get some messages, we get the errors that might have happened, and here we get a note that the dataset Milford has 24 rows and 6 columns. Okay, well we want to have a look at that dataset, so we'll press the View Dataset button. And here's our dataset. What is it? This data, believe it or not, is data that a colleague of mine was working away at in a course that we were teaching in Invercargill, and it's about annoyance of trampers on the Milford track by day visitors who are there on the first day. So they're asked 3 or 4 days later at the end of the Milford track, were you annoyed by the day visitors that you saw on the way? And Michael had finished the exercise and was starting to play with his own data. I took one look at it and thought, wow, that's miles better than the artificial data we've been using for teaching. Can I have it? And I've been using it ever since. And what do we have? Don't worry too much, these are the actual numbers. What we've got, the 2 we're going to use here are the number of day visitors, the X variable we're going to use, the stimulus, how many day visitors came that day, and in the second, in this column here, we've got the annoyance. What percentage of the trampers who were interviewed were annoyed by the number of day visitors the previous 3 days earlier before they were interviewed at the end of the Milford track. So what can we do with this? That's a good question. What was I going to do next? I think I was going to create a graph. That's what we teach. First thing you do is explore your data. We teach in our course. So let's have a look at that. And so we can actually go to K and ggplot, and we want a scatter plot. Scatter plot. We want our X variable as the number of day visitors. Our Y variable is the level of annoyance. I hate serif fonts, so Yarp taught me that, so that's here in the audience. And that'll do. So that was just an optional extra, but we need to choose an X and a Y variable. If we want to, we can add in a smoothing line. We're actually starting, as we graph, we're actually starting to model without realizing. So we can add a linear regression, or a low S or tight smoothing line. So what should we have? Well, I think a low S without a confidence interval. Could add a confidence interval if we wanted to. Do that, press enter, and hey presto, we've got a graph. A very tidy, good graph created by GG. Can I sell people a linear model for that data? Does it look as though there's a response? Could we draw a straight line through that? I'm prepared to anyway, that's what we do in our course. Perhaps a little bit of curvature at the bottom. There's other ways you could analyse this data, but that's a good starting point and a reasonable place for introducing a linear regression. What do we see? The code that's produced, the code produced by ggplot is a little bit complicated. In fact, quite a lot more complicated than we need. How we teach this, classes, we say, well, that's a bit complicated. It's set up to do complicated analysis as well as easy things. But how we teach it is we say, well, now we're actually going to take that code, simplify it down, and then we're going to run it as just directly as code and see if we can produce something like the same plot. So we need a ggplot. We need a data equals Milford. These are the key elements of a ggplot command. We need an aesthetic, an AES, which tells us that our X variable is day visitors, and our Y variable is annoyance. Let's set up our basic unit. The other thing we need to do is we need to add on a geometry. What sort of geometry do we want for our graph? Gem_point, and let's see with a little bit of luck that code.
You've got a ggploid instead of plot.
Thank you very much. You can simply introduce them. If you're lucky, somewhere in another window will be a graph. Not the same one. We'll teach people how to turn what you see in the script window into code, and you start coding yourself. You do that throughout the course deliberately to use R Commander as a bridge to writing your own code and creating useful things. Okay, we can go on. I think I'll skip at this point. It's in the notes. We're to run a linear model, run the standard 4 diagnostic plots for a linear model, for his data, and so on. I'll just go back to the presentation if I can find it. And there's some slides there that show you some of these things. Activating the linear model, the standard outputs from the linear model. Sure enough, the responsive day visitors to crowding shows a coefficient of 0.31, and it's very highly significant. And we can run the standard diagnostic plot, which don't look too bad. You could argue for some other possible approaches. But that's R Commander. So barriers to adoption, we'll come back a little bit to this. Getting help with an R is a bit more difficult. It's highly variable. Most help files are of limited use to the uninitiated. Good news is that the files developed by Hadley Wickham with the key ggplot and reshape packages are excellent for their help. We'll have websites that are excellent for finding the help that you need along with books. And that's the sort of direction that I argue here that R needs further development. That's the direction that R support needs. Packages need the sorts of things that Hadley Wickham's providing to support the packages that are reasonably user-friendly for people who are getting into it. And R Command was the other big step forward because it allows the transition into R. Okay, a little bit here about graphs. You can look at the slides for that. A new challenge for me in terms of training is to learn to use web-based environments. You can check that slide. It's just a slide. And now it's time for Peter to come back, and we'll aim to finish within the next quarter of an hour, 20 minutes, I think.
Yeah, I'll be quick. Thanks, Ian.
That's the last segment. Getting to the end. So we're now discussing towards the end, looking at meeting needs in MB and then trying to draw it together with a few lessons or conclusions from our experiences. So training at MB had many similarities to DOC. That was we're aiming to equip analysts to do more and better analysis, bringing the data to life and making it available for going into decision making. Different context, the initial focus was on a tourism research team of 6 or 7 staff. The aim was to make R the tool of choice for much of their work and to allow, we also decided to be on that would allow other MB staff to observe the process and become involved to the level they were able to. And for the tourism team in particular, this was a big commitment once the decision was made to use R as the workbench for much of the work there. The approach we took was to hold group seminars each month looking initially at things like handling data in R. We in fact went through relevant R commander menus, didn't have time to look at them, but they were quite useful for people just to learn about some of the things available from R in a user-friendly way. Dates and seasonal adjustment in R were very important, things like decompose and so on, and the interface to X12, which actually remains the one remaining problem we have at MB, and that is that the tied-down system there, same as at DOG, doesn't allow us to interface readily to the X12 executable file. We're hoping to solve that. Whether we will remains to be seen, I think. And the other sorts of models that I've touched on already, the linear model, regressions and Vanovers and so on, generalized linear models, additive models, tree models, etc. We use tourism data primarily and other data as examples. The sorts of problems that arose in people's own work, simplified sometimes, as examples that we worked through. Staff would, for example, present at these seminars something that we've been working through in the days I was in the office and the work they've been doing. And it was hands-on. The ability to do hands-on work is actually essential for this sort of development. It was limited at first because the computer lab at MB was already overbooked through part of the realignment of the organisation. Once we had it available, it's also made a big difference. So on that first stage, there was quite a bit of individual coaching, assisting with real work problems and presenting some of those results at the monthly seminars. And I would come up in person 2 days a month to work with staff and run seminars. And in between, we'd run phone and shared desktops from Christchurch. So some of this work could be done remotely on a weekly basis. There was rapid progress after a few months. The first, as I think is already outlined, I think had to solve some basic challenges of accessing data and developing the sorts of common tasks using R that people were running across, but rapidly became a tool of choice for analysis for things like the International Visitors Survey, the regional tourism indicators, and so on. And developed a critical mass of our users within that group who were able to support each other, as well as relying on Peter's expertise and with advice and the access to me once a week. Now, after 6 months of that, we've developed onto a new stage where, again, now I just come up to Wellington for a couple of days a month and run two monthly seminar series, an intermediate level series that carries on with the staff who've already been exposed to R, either in the previous series or in previous work. And we've started a new basic series for new staff in the core team and for wider MB staff, and it's pretty much fully subscribed with 10 staff attending virtually every session that we're running. And we're using R Commander integrated right into that from the start. It's working well, and with the computer lab now available, we're able to adjust our teaching so there's much more interaction with the computer and real exercises going on. It makes a big difference, and some very limited individual coaching in the 2 days that come up. So what lessons would we draw from our experiences at DOC and MB? Well, R has wonderful features. It features the latest statistical methodology. It's fast and flexible. The data, in tandem with there's a typo there, with the database management system. The results that when you work with R, you produce code, and that means that you can reproduce exactly the same thing at a click. It's a huge difference from doing point and click. The other side of the same coin is that it's repeatable in a new context. Your data changes slightly, your data gets updated for another year, another quarter, another month or whatever, or the whole data context might change quite a lot, but that data, often that code can be adapted rapidly for small changes and with more work for larger changes to a new context, and you're away, starting from a base you've already developed. R has great presentation tools, and hope nobody needs further persuasion on that. Tables and graphs, it's easy to move those rapidly into other places like Microsoft products like Word or PowerPoint, or into LaTeX if people are using that, and so on. A key feature, which probably should have presented even more strongly, it is a large and growing user community. The interest that this seminar has shown is just one aspect of that. I mean, I don't know, Peter and I, my guess was it might be 20 or 30 people come along, if we were lucky. We had 100 registrations, and there's at least 60 or 70 people here today. So there's a growing user community of people who are interested in it, and a community that's based for huge developments going on. And last but not least, it's free. Not only does that mean that it's easy to persuade your organisation to get it as an extra, but it also means it makes it easier, shall we say. They can't say it's going to cost anything directly. might cost indirectly, that's something you have to evaluate. But it's free means you can download it at home. People are going to be able to take those tools with them to other places readily. They're not stuck with staying in SAS houses or SPSS houses or whatever. So the skills that staff learn in that are transportable from one part of an organisation to another, from organisation to another organisation, for training, all those things. In fact, it does have a learning curve. The lack of point and click, we've seen a partial overcoming of that, and geeky documentation. Okay, but let's have a look at how we can deal with some of these issues from our experiences. How do we deal with some of these issues? Our commander is a bridge. Access to resources, there's tons of resources out there. I know in Peter's notes on the slides, the quotes from one of the staff there who was a heavy SAS user, who said, that he could find, by a quick search on the internet, he could find an answer to his questions in 10 or 20 minutes, which would take him 2 or 3 days in SAS. That's what I do. Go into Google, you put R in whatever problem you've got and see what comes up. It doesn't always solve it, but it often does. So you've got, and if that doesn't solve it, you can ask questions on some more friendly R lists and the occasional not so friendly R list. Don't be surprised if you get a blast from some people on the occasional R list and find out which ones are more user-friendly before you ask a question. There's a guy, Ripley, who's famous for ripping into people on R users. He's a brilliant guy, but that's perhaps part of the reason. It's so obvious to him and it's not so obvious to us. Search, ask questions, there's books, appropriate training and mentoring within organisations and beyond, and joining and developing the community of users. It's worldwide, local communities, people who want to share. Your colleagues should develop a critical mass within your own organisation or sphere. And there's user groups as well, which I'll come back to in a minute. Okay, final section here is just looking at our usage in the state sector, and then a question or two towards the end. R in government departments, core government public service. It's the core statistical package at DOC, and when we upgraded from R2.9 to 2.15 recently, there are about 70 plus users. It's a key package for tourism and sector performance at MBIE, and there's 3 and now growing important official statistics data sets using R in production. Statistics New Zealand I'll come back to on the next slide. Inland Revenue, MSD have limited usage of R, and other people using R in a core public service?
Customs.
Customs? Limited or widespread?
I'm the only one at the moment, but we have no other statistics package.
Yep.
We have no statistics package at all.
Yep. So you don't have to argue with that.
And in this environment, cheap is good.
Yeah. Especially cheap and good.
Cheap and better, yeah.
Cheap and best. Yeah. Are there other people here from other government departments interested? Yep, some other ones in the
Matter, are
pack.
you the only person that uses
Which
it?
one?
MBIE, Ministry for Permanent Industry.
Oh yeah, good.
Yeah. Ministry for the Environment, I think we've got 1 user.
Two users at
Good. Well, we want to continue finding more out about that. At Statistics New Zealand, it's important because Statistics New Zealand is the core of the official statistics system. They do use SAS for their production systems. It's fine. It's very good for very large data sets. In fact, if I was doing statistics with very large data sets, I wouldn't look past SAS probably. Well, I would look past SAS, but I would use SAS. At least it's my first port of call for my experience with Statistics New Zealand. But R is available at Statistics New Zealand for analysis purposes, and many people are now coming to Statistics New Zealand with at least basic R skills. And they're developing, this is a report from John Loptel at StatsNZ, the Statistics New Zealand interest group on the future use of R at SNZ, and he reported a few points, and I just picked out a few of them. They're looking at improving deployment and quality control for code, training and mentoring, identifying where R can improve efficiency and quality. They're aiming to share experience with other statistical offices like Statistics Netherlands, and I think one other mentioned where they are using R, and discussing whether R should be limited to analysis rather than production. So those questions are open for discussion at Statistics New Zealand at the moment. That's an important development. And there's our in the wider government sector. I'm aware of our users, and between us we're aware of our users at Food Standards, Qualifications Authority, there'll be some code being used there, at Building Research, Wellington Regional Council, and some penetration in the health area. Plus other places that people can mention. Whatever. Yep. There's increasing interest in R in the research sector. It's of course in very wide use in universities. It's certainly generally the package of choice for most academic developers, not all but most. Growing use in Crown Research Institutes. At most of the Crown Research Institutes, quite a lot at NERA, I was just told this morning, but I picked out the two largest CRIs. Ag Research Report, colleague there reported that younger statisticians arrive as experienced R users and are encouraged to continue to use R. Other statisticians are making increasing use of R. And they run R courses for scientists at Ag Research. At Plant and Food Research, the other very largest CRI, 10 to 20 staff rely on R for their work, and another 20 to 30 use R on a reasonably regular basis. We see a growing use of R throughout the wider public sector. It's working for us at DOC and MB and growing in the rest of the state sector as it is in the rest of the world. And just a final few final slides. The way forward, and the question we'd like to pose is there interested in an R user list or group focused in Wellington, and probably if it's going to be focused in Wellington, it's going to be mainly focused on the state sector. But possibly virtual communication, but probably on a geographic basis, considering having physical meetings. So the question would be whether people are interested. Is there anybody who wants to indicate interest in doing something like that?
I think your answer is the amount of people here.
Exactly. So what we suggest is that we may aim is to circulate a request to express interest and develop something via an email list from the seminar. One possibility, which I discussed with John Haywood this morning, is to set up what's called the Wellington Statistics Group seminar. That could also be an overall meeting of our users in Wellington with a focus mainly on the state sector and